Today we're going to finish up our notes on dilations of points, lines, and line segments. You can also include the data 5-4 at the top with your notes from last Thursday. Last Thursday we did cover these first 4 pages of notes. Today we're going to finish up these 3 pages of notes, and we are going to skip around a little bit. So in previous lessons, we have dilated figures about the origin. So how does that change if it's simply a line segment? So in example number 10, we're going to dilate about the origin using a scale factor of -1/3. In our previous lessons, when we dilate about the origin, we can simply use a multiplication rule to come up with the new ordered pairs. So I'm going to start by multiplying -1/3 times 3, and then -1/3 times 9. The negative scale factor will place my image over here underneath the center of dilation. So when I multiply it, my new ordered pair for D prime should be -1, -3, and we're going to place a point there. And then when I multiply the -1/3 times 9 and 3, I'll have a new location of E prime at -3, -1. And we can go ahead and use our straight edge and make our line segment. So the segment's been dilated to a scale factor of 1/3. It's 1/3 the original size, and the negative scale factor places it underneath. Let's try this again with another line segment. We're dilating by a scale factor of 1/2. The positive scale factor will keep it on the same side as the pre-image. It will just move it closer to the center of dilation. And again, as we dilate about the origin, we're going to multiply 1/2 times 6 and -4. So our new location for A prime is at 3, -2. We'll also multiply the 1/2 times B. So that will give us a new location at 1, -4. And we can take our straight edge and create our smaller line segment. So we can see when you dilate a line segment and the center of dilation is not part of that segment, we are actually creating another parallel segment. You're going to skip to find the next set of examples where we're dilating lines. So instead of having the segment start and stop in an exact location, we know that a line will continue on in 2 directions infinitely. So if we want to dilate a line about the origin, I'm going to first plot this line using my y-intercept and the pattern of the slope. So there it is. The center of dilation is right here at the origin. So we're going to dilate with a scale factor of -2. So what that will do is create another line, but it will be below the center. Because we're using the origin, we're going to multiply. So I'm going to locate 2 points on my line, 0, 2, and 4, 3. When I multiply both the x and the y coordinate by -2, I'm going to have 2 new ordered pairs of 0, -4, and -8, -6. So what I'm going to do is draw a line. 0, -4 is right here on the y-axis, and -6 down. All right, so I'm going to graph my line through those points. What I hope you'll notice is that the new image is on the other side of the origin, but the line I created actually looks parallel to the existing line. And when I check the slope on it, I do have a slope of 1/4. So when 2 lines have the exact same slope, that does confirm that they're parallel. Let's start with our same line and dilate about the origin with a different scale factor. This time we're going to use a scale factor of 1/2. So I've selected 2 points on the line. They can be any 2 points, but since I'm using a scale factor of 1/2, I'm selecting points that have x and y coordinates that are multiples of 2. So when I dilate, I'm multiplying both the x and the y by half to get 0, 1 and negative 4, 0. So when I create the next line that goes through both of those points, if I double check the slope, we're going to rise 1 and run 2, or run 4. And we can see that the slope is the same as the original, and I did in fact create another parallel line. So it looks like when you dilate a line about the origin, you're going to create another parallel line, either closer to the center of dilation or further away. We can also take our line and dilate it through another point that doesn't have to be the origin. So I'm changing my equation to 1/2 x plus 1. I'm going to go ahead and plot that line. Our center of dilation will be at 2, 5, and I'm going to mark that with a giant red dot. So we need to dilate about point C with a scale factor of 2. So we're going to push the new line twice as far from the red dot. Now, if you think about when we dilated points in the last lesson, because this is not centered at the origin, I cannot multiply. I actually have to look at the pattern of the slope. So I'm using 0, 1 and 4, 3, and let me just highlight those on the line. I'm going to look at the slope. So from the center of dilation to 0, 1, I have to go left 2 and down 4. I want to do that pattern again. Left 2, down 4. So as I'm counting the pattern from the center of dilation, I'm going to go ahead and plot that point. We're going to do the same for 0.43. So from the center of dilation, it's 2 right and 2 down. I'm going to also go 2 more right and 2 more down to locate my new point. What you'll notice is the center of dilation and the 2 image points are all in a straight line. So my points are at -2, -3, and 6, 1, and I'm going to graph my line through them. If I check the slope, I'm rising 1 and running 2. My new image has the same slope. So again, I have created a parallel line, even though the center of dilation was not at the origin. Let's try another example with that same line. So let me graph it. Center of dilation is still at 2, 5. We'll use a nice yellow dot there. And we're going to dilate it by a scale factor of -2. So my new image should be above the yellow dot. So we're going to identify 2 points on the existing line. I am using 4, 3 and 6, 4. You can pick any point on the line, but keep in mind we have to go up to the center of dilation and then move away from it twice to get my scale factor of 2. So if I start with 4, 3, I'm going to rise 2 and run left 2. Rise 2, left 2, rise 2, left 2. So I have to do that twice to be twice as far away. And we'll plot that point. We're going to do the same with 6, 4. We're going to rise 1 and run 4. Rise 1, run 4, and one more time, run 4. And I've got another point here. So my new ordered pairs that will be on my image are -2, 9 and -6, -7. We can go ahead and graph a line through those 2 points. And if I want to double check the slope, rise 1, run 2. That confirms that I have the same slope as the image. So in all these examples so far, whether we're dilating through the origin or not, we are creating parallel lines. We're just moving them according to the rules. In our final example, I'm starting with the same line, the same center of dilation. This time, we're going to dilate about point C with a scale factor of 1/2. Again, because this is not the origin, a multiplication rule will not work. So I'm using 0, 1 and 8, 5. If I look at the pattern going from 0, 1 up to the center of dilation, I would have to rise 4 and run 2. I'm going to cut that distance in half, and I'm only going to rise 2 and run 1. So that red point is my first new location. The 0.85 is over here. I chose this point because it's just a horizontal distance to the center of dilation, but it looks like it's 6 blocks, so I'm going to cut that in half, and I'm going to move in half the distance, so 3 blocks. My new points are at 1, 3, and 5, 5, and we can go ahead and graph a line through them. And again, I'm going to double check the slope, but I'm rising 1 and running 2, so a slope of 1/2. So when you dilate segments or you dilate a full-blown line, when your center of dilation is not on that line, you are creating parallel lines and parallel segments. So if you'll flip back in your notes to where you see these images, even though in previous lessons we dilated full figures, the last 2 days of lessons have talked about dilating points and dilating segments and lines. Really, that's what your images are made of, your figures. So if I were to dilate this triangle, one of the sides does contain the center of dilation. So A is moving twice as far away, and B is moving twice as far away. Because the center of dilation is on that side, the image A prime, B prime is the same line. On this figure though, when I dilate CB and I dilate AC, those lines are going to be parallel. So just like when we dilated segments and lines, the center of dilation is not on AC, which makes me create a line that is parallel to it. In this image, you can see the original triangle ABC. Again, you're either dilating a single point or we're dilating a single line segment. It's just that the figure contains multiple of each. So when your center of dilation is not on any side of the figure, dilating side AB will create a line segment that is parallel to it. And then all the other sides contained on that image will also be parallel to its original pre-image. This homework was assigned on Thursday. It's going to count as both homework 121 and 122. Please answer all the questions. If work should be shown, then you should definitely show it to me. And I'm going to count this assignment as 2 homework grades. If you have any questions about the homework or any of the problems, please make sure you get in touch with me. Otherwise, have a great day.